Okay, so in the last video we looked at loading and storing. We also have done some input and output in the introduction and how to stop the program. So that's the current code summary of what we've seen so far. And now we need to look at how to actually do some calculations. How do we add and subtract in Little Man Computer? So addition, you use the mnemonic add, ADD, it's quite an easy one to remember. And also here you can use a variable name afterwards to refer to a location that you want to get that data and add it to the accumulator. So as it says here, the add instruction adds the value stored in the given memory location, so the one that you've named with a variable, you've labeled with a variable name, and it adds it to the accumulator. So whatever's currently in the accumulator, it grabs the value from that memory location and adds it to it. After the value has been loaded into the accumulator, the program, added into the accumulator, the program counter will move on to the next memory location. We've also got subtraction, which is sub, and then you can also put a variable name as I said before. And the subtraction instruction subtracts the value stored in the given memory location away from the accumulator. So you have whatever's in the accumulator, and it subtracts the number that is in the memory location from the value that's in the accumulator, not the other way around, which is quite important to remember. Okay, and it moves on to the next instruction, as most instructions do. So for this activity, you can use a pen and paper to write down the LMC programs, and then when you think you're finished, have a go at using it on the computer to test it out. So pause the video here, and then I won't show you it written out, but I will go through the solutions on the LMC. Okay, so we first need to create a program which takes in and stores two inputs from the user and outputs the sum of them. So we just need to take in two inputs and output whatever they are when we've added them together. So let's go to Little Man Computer. So we need to take an input and add, two inputs and add them both. So I know I need to take an input first. So it's a good place to start. I know because I've got two inputs, I'll have to store at least one of them in the memory. So I'll store the first one as STA first into the memory. And I need to take a second input so I can add them two together. Now, do I need to store this in memory? Well, no, because when I take the input, it gets put into the accumulator. And if we use the add instruction, it takes something from a memory location and adds to whatever's already in the accumulator. So there's no need to store this into the RAM. So what I can do is just, after taking the second input, I take whatever's stored in the memory location I've labeled first, and I add it to that second input, which is currently in the accumulator. And then the last thing I need to do is output the result. And remember to halt. And of course, I've used a variable name or address label called first, so I need to tell it that first is an address label to reserve some memory location for the storing of data. And it all looks fine. It looks like all the code is loaded. So if I run the program and speed it up, if I put 5 and I add 10 to it, then it outputs 15. Okay, so that's the first task done. And the second task is to create a program which takes in 3 numbers and stores them, and then outputs the sum of the first 2 with the third subtracted from it. Okay, so we break it down. Again, we need to take in 3 numbers, and it says to store them all. Oh, I've just realized in that task before, it does actually say store the numbers. So what you should have done, or what I should have done, is actually stored it as second, but it's a pointless step because the program works without doing this. But as it says in the task, we should probably do it. But that still works. Pointless step. Okay. I go back to the questions. So create a program which takes in 3 numbers and stores them, and outputs the sum of the first 2 numbers with the third subtracted. So we need to take in 3 numbers. So I need input store first, input store second, and I'll need a third input. And it tells me to store it, so I might as well store it as third. And I can write third dat down the bottom. Now I need to output the sum of the first 2 numbers. So I need to take the sum of the first 2 numbers and then subtract the third from that sum. So, because the last number I entered in was the third, it's the third input, I need to load the first, because it tells me just the sum of the first 2 numbers. So I need to load the first input, which I stored in first. And then I need to add the second one to it. Add second number. So this is all happening in the accumulator. I've loaded the first number into the accumulator. So it's gotten it from memory, sticks it in the accumulator. Then I'm finding the second number that's stored in memory and I'm adding it to the accumulator. So that what I'll have in the accumulator then is the sum of the first 2 numbers. And then the last step is to subtract the third number from that sum. So I've loaded first, I've added the second, and I'm going to subtract sub third. Once I've done that, I've got the answer I want to output, so I just output it. And then I halt, so I can delete these 2 lines from before. Okay, and that's the code you would need for that. So I just test it, running through it. So if I do 10 plus 20 will give me 30. And then if I take away 5, it should output 25. And it does up there. Okay, so that's addition and subtraction 1. Here's addition and subtraction 2, so we've got a few more tasks. Now these get a bit more complicated, but I want you guys to try it. So if you create a program which takes in a number, doubles it, and outputs the result. So think about it, you can't use multiplication in LMC, we can only use addition and subtraction. So how could we write a program which takes in a number, how can we double that number? So I'll let you have a go, pause this, and then I'll show you the solution to that one. Okay, so in order to double a number, what we can do is just add it to itself. So I just get rid of all this code. So I want to take an input. If I store it as a number, so store number, whatever I've typed in, and then I can, because that number is already in the accumulator anyway, because it's the input, I've stored it, but it's copied it into memory, it's also still in the accumulator. All I need to do is then add number. So I've taken an input, it's stored that in an address labeled number, which will be over here somewhere, and then I've also added it back to the accumulator. So that will actually double the value. I then output it, halt the program, and remember that I've used the variable name number, so I need to actually use the dat instruction to tell it that. And now if I run this, I'll just show you this running actually. So it takes an input. I was struggle 21. So 21 is currently in the accumulator, and now it's also storing it into address 5 there. Now this instruction is telling it to add whatever's in address 5 to the accumulator. So 21's there already. 21 plus 21 gives me 42. So I've doubled the value, and now the next instruction is to is to output. So it outputs 42. So I've taken an input, I've doubled it, and then I've output it. Okay. The next program, create a program which takes a number and multiplies it by 8. Now there's a couple of ways you can do this. I'm going to let you guys have a go first, and then I'll show you, well, a couple of ways you could. But one way is definitely better than another. Okay, so pause the video here. Okay, so we need to take a number and multiply it by 8. Now, we've worked out how to double the number here. One way you could do this is if I've got the original number once, I can just add it to itself 7 times. If I just copy and paste this a few times. So we've got 1, 2, 3, 4, 5, 6. If I do it once more. So by adding a number to itself 7 times, then it's basically the same as multiplying by 8. So I'll just show you that running. So 5, and it returns 40. It's multiplied by 8. Now that works, but there's a better way of doing this. So when we double a number, if we store it and then add it to itself, so that's times 2. We've multiplied it by 2. If we store it, that result, we overwrite the number. What that actually does is it allows us to, if we add it to itself again, now it gives us times 4. So I'm taking a value, so it's times 1, it's 1 of the value. I add to it, so that would be times 2. So it's multiplied by 2 now. So think about this as how many times it's been multiplied. So times 2 on this line. I've times by 2, and then I've overwritten the original value. So this is the number times 2, and I'm adding the number multiplied by 2. So now this is times 4 at this step. So if I store that, I multiplied it by 4. And so if I want to get to times 8, all I need to do is double it again. So to do that, we just add the number again. And now we'll have times 8. So I take a number, which is times 1. So it's the number itself. I add itself to it, which is now times 2. And I overwrite the number. If I double that, it'll go to times 4. And then I store it again. It's times 4. If I double that again, then it's times 8. So each time you perform this step, store number, add number, you're doubling the value. So we double it once, double it twice, double it 3 times. That gives you times 8. So if we run that program, we should see it does the same thing. If I put in 5, see if I can hit right. Yeah, so times 40. So it's actually a slightly shorter code, and it's just a clever way of doing the program. That just gives you the same output. So we've done that. The challenge task is tricky. Have a go at it. So pause the video here, and I will show you how to do it afterwards. Okay, so obviously one way you could do this is just to add the number to itself 39 times, but that's quite a long code, and we can be a bit more clever in how to solve this one. So what we should try and do, I'm going to get rid of all of this for now. So if you think about it, we want to keep doubling a number. If you double it once, then it's times 2, double it again, times 4, double it again, it comes times 8, so that's what we did in the last program. But if you keep doubling a number, it'll become times 16, times 32, and then times 64. So it never actually reaches times 40 by just doubling on its own. So there's multiple ways you could answer this. You could maybe keep doubling it until you get to times 32, then add the original number 8 times. So then it'll get you up to 40. You could double it a few times. There's many ways you could do this, but the way I'll show you how to do it is how you can get to times 40 by being a bit more clever. So for this, you actually need two variables. So I'm going to have number and original number. It's quite a long variable name. Probably should have used something different. So I'm going to store the number. I'll take the first input. I'll take the number in. I store it as number, but I also store it as original number. And what that does is means I've got a copy of the original number that I originally had. Even though I'm going to keep updating this number, because we're going to keep doubling it a bit, I'm going to have a copy of the original number when it was just itself, times 1. So the way we can do this is if we double it twice. So if I load number, actually I don't need to load it, do I? Because it's in the accumulator already. So if I add number, then store as number, I've doubled it once. So 1 times 2. If I do it again, add number, I store number, 1 times 4. Now, as I've said before, if we keep doubling, we won't get to 40. But if we add the original number to this, so 1 times 4, and I add the original version times 1, what I'll get is the original number times 5. So if I now add the original number to it, I've got the number which is currently at times 4 of the original, plus the original itself will give me times 5. So now, if I keep doubling this, it'll become times 10, times 20, and times 40. So if I store that as number, it's currently times 5. I add number to itself, becomes times 10. I add the number to itself, becomes times 20. And I add the number to itself again, and that should be times 40. So if I output this and halt the program, hopefully that should all be working now. Need to test it, make sure it's working. Actually, maybe I'll show you this running just to make so it's clear what's happening. So the original number I'll put in is 3. So 3 gets put in the accumulator. Okay, I've also stored that as the number. So it's been stored in box 16, as it says on instruction 1 there. But I'm also going to store it in box 17, because I've stored it as number, which is a label for box 16, and I've stored it as original number, which is a label for box 17. So I've got the original number 3 in 2 separate places. Now I'm adding the number to itself. 3 plus 3 gives me 6. So I've added the number, and now I'm going to store it in box 16, in the box that's labeled number. So 6 is now going to overwrite the number 3 there. But I've still got that original number 3 for later on. Okay, now it's going to repeat that again. It's going to do 6 plus 6, so it's doubling, and it's going to overwrite what is in box 16, overwriting the box, the data in the label, in the address labeled number. So now in this box, we've got the original number times 4 and multiplied by 4. It's gone from 3 to 12. But I've still got that original 3 here. So the next step we did was to add the original number 3 to what's in the accumulator, which is 12. So 12 plus 3, I got 15. So now the original value has been multiplied by 5. We're going to overwrite what's in the accumulator. And then the same process happens again and again. We just keep doubling. So 15, we're going to add 15 to itself, which will give me 30. So doubled it there. So remember that's times 10 because we had 3 originally. Overwrite that, so it's 30. And now we're going to double that again. So fetch what's 30 plus 30 is going to be 60. And then doubling it once more, because we went times 40, so obviously 3 times 40 is 120. So we do 60 plus 60 to double that. And now we don't store that because we've got the answer we want, we just need to output it. And it outputs 120. So input 3, it multiplied it by 40 and gave me 120. So obviously that's a challenge task for a reason, it's quite complex and the way of thinking about it is not straightforward. But hopefully I've explained that well enough so you can understand what's going on. Okay, so that's the end of addition and subtraction. I think next one will be showing you how to do branching, how we do selection and if statements essentially in assembly language.